And in the structure of the atom, you have orbitals. This is the s orbital, the p orbital, the d orbital, the f orbital. Alright? But before you do that, alright, we need to know that there is something called the quantum numbers. Now, the quantum numbers that we are talking about is the number of, that number is used to determine the position and the energy of electrons. Alright? It's to determine the position and the energy of electrons. And then we have the azimuthal quantum number. And in that azimuthal quantum number, we have four of them: azimuthal quantum number, principal quantum number, azimuthal quantum number, magnetic quantum number, and spin quantum number. But the azimuthal quantum number shows the distance of the electron from the nucleus. And this principal quantum number shows the distance of the electron from the nucleus. And this is known as the KLMNO. Alright? So we can now use the principal quantum number here, which is the KLMNO. If you want to finish it, it's KLMNO. Alright, now I will say that I need to know that the first shell, if it is the first orbital, which is the S, it is equals to the K shell. And that is having one orbital. So it is the 1s. If it is the P, which is the L, is also having, is the second orbital, alright, which is the 2s and then the 2p. If it is the D, which is equals to the N, it is the third orbital, which is the 3s, 3p, and then 3d. If it is the F, which is the N orbital, which is 4 orbital, the fourth orbital, it is the 4s, 4p, 4d, and 4f. Now you can fill in the rest by saying this is 5s, 5p, 5d, 5f. You can say 6s, 6p, 6d, 6f. You can say 7s, 7p, 7d, and 7f. Now, according to Alpha-Bound says electron filling the orbital starting from the lowest energy level. Now, the lowest energy level here is the 1s. So you first have the 1s2. After the 1s2, look at my hand. Just follow my hand. You have the 2s2. After the 2s2, what's the next? 2p. After the 2p, 3s. After the 3s, 3p. After the 3p, 4s. After the 4s, 4d. After the 4d, 4p, 5s. Like that. Like that. Cancels out. And then it 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 cancels out. Now, if you have these understanding, you also need to know about degenerate orbitals. Now, if it is the S, we have the S, P, D, F. Now, the X degenerates. The S block, it has one-fold degenerate. It has one-fold degenerate, then if it's the P has three-fold degenerate. If it is the D has five-fold, 1, 2, 3, 4, 5 degenerates. If it's the F have seven-fold, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. Now, having this understanding, you can now write the electronic configuration of any atom of element of your choice. Now, let's just pick anyone. Let's say, what's the electronic configuration of sodium? This sodium, and then this sodium. You know, this sodium has become ionized. It has lost an electron. This sodium has not lost an electron. There is no reaction. So the number of atomic number here is 11. So the electronic configuration of sodium here is the 1 1s, 2s, and then 2p. Now, it is 11. And if it's 11, we have number of electrons that can enter the s. According to what Stu says, it's just 2. Electron field is singular before pairing or core. Number that can enter the D, according to L3, is 6. Number that can enter the D is 10. Because 5 times 2 is 10. 7 is 14. Alright, 7 times 2 is 14. Now, for the sodium, which is 11, we call it 1s2. Have we got it to 11? No. You will be doing it until you get to 11. 1s2, 2s2, 2p. For the p is 3-fold digit. Where is it? 3-fold digit. 1, 2, 3. 2p what? 2p. If I add, what will I add to 4 to make it 11? I need to add, what will I add to 4 to make it 11? About 7. Okay? So for here, which is the p, can only contain 3. So I can only contain 6 electrons. So I'm going to have 6 provided. 2p6. And 6 plus 4 is it up to 11? No, I still need one more electron. So I will now go here. I will have, follow this one. This is 1s. You see that? 2s, 2p. The next thing is 3s. So I will have 3s1 that is remaining. This is one. When the electron is now filling in the orbitals, it will fill it singularly before pairing or come. So when one is filled, pair will come. When one is filled, pair will come. When one is filled, one is filled, one is filled, pair, pair, pair. When one is filled, we are up to 11 now because it's only one that's remaining. Now, if you're asked to find the number of unpaired electrons, now, the number of unpaired electron here is just 1. The number of unpaired electron in sodium, not reacting sodium, is 1. But the sodium here is reacting. So let's take care of that. The sodium here is reacting. This sodium gives out an electron to become positively charged. So it is now 11 minus 1. 11 minus 1 is 10. If 11 minus 1 is 10, the electron configuration will become 1s2. In case you are out to interpret, this is just 1s2, 2s2, 2p6, and 3s1. That's all. Alright? So we go to this one. This one is 1s2, 2s2, and 2p6. Why is it 2p6? It's just 10 electrons. So we'll fill in the electron, you fill before pairing, you fill before pairing, for pairing. Now if they ask you, how many unpaired electron is a sodium positive charge atom of element? No unpaired electron. There's 0 unpaired electron. Let's do another one. Let's say you are asked to find the electron configuration of chlorine. Let's find for chlorine now. I believe you have been able to put this in your note anyway. The S block has 1-fold, the P block 3-fold, D block 5-fold, F block 7-fold degenerate. You should know that. Very important if you want to fill in the number of electrons in the degenerate orbitals. Alright, let's just pick randomly. Let's say we have chlorine and chlorine. Now, this chlorine is 17. This one is not 17 because it's given an electron, it will become 18. Now we have, for this chlorine is 1s2, 2s2. Well, in case you ask like this is 1s2, 2s2, 2p6. Very simple. There can be a question in JAMB. What's the configuration of sodium positive charge? Please, this is the answer. Be careful. When it's inclusion of the electrons, it becomes 10. Up to 10 because 1 minus 11 is 10. Alright, let's come back to chlorine. This chlorine is not losing any electron, it's not getting any electron, it's just a neutral atom. So if it's a neutral atom, it's 1s2, 2s2, 2p6. Why is it 2p6? We are going to 11, following this direction, following this arrows. 2p6, 3s2, that should be 12. So we need about 5. What do we need now? About 5. P is 3-fold degenerate. So it's 3p5. Now let's fill in the orbitals. Now we have 1, 2. Well, let's pair. We are alright. We get pair. Alright? Now this is just 1, 2, 4, 2 electrons, not pair. Then we have 1, 2, 3, 5, isn't it? So we're putting 1, 2. 3 plus 2 is 5. So we have 1 unpaired electron in chlorine neutral atom. So the configuration is 1s2, 2s2, 2p6, 3s2, you can see the configuration, then 3p5. So that's all we've got for the chlorine. Now let's go to this chlorine. This chlorine is negatively charged. That chlorine over there is negatively charged. And it's negatively charged, it means that it's receiving an electron. It will receive an electron which is known as reduction. The one of sodium is called oxidation. This is called reduction. Now in this case, what we're going to have will become the chlorine now becomes 18, no more 17. 1s2, 2s2, 2p6, remember this is threefold, the p block. Let me take this up. Let me take this up. Okay, I have the ring is in the electrode, and then this become 3s2. This one become 2p6 because we are going to 18. So we pair now. Pair, singly before pairing, pair, like this. So this is now the electrical configuration of chlorine, which is like this, is 1s2, 2s2, 2p6, 3s2, and 2p6. Alright? What about 1s2, 2s2, 2p6, 3s2, and 2p6. You see, there is no unpaired electron in the chlorine with the negative charge atom element. Okay? An ion, a chlorine ion. Alright? Now, I hope you've got this question, you've got this understanding. This is how the question will come in JAMB. Let's give you a typical JAMB question. Look at the way it will come so I can round up for you. They'll ask you the electrical configuration of the element, the electronic configuration of the element calcium plus 2, potassium. Let me fill up some space for us. You know, you should have this in your notes now. Then let's say I've done sodium, I've done chlorine, so I'm not doing again. Sulfur minus 2, and then we say calcium. Now, they will just put this one, or put this one, put this one, put this one. Anyone they put them, you can now solve. I believe you can solve that. What I'm going to do, I will solve this, and maybe this, and then I'll leave the other one for you in assignment. And if I ask you what is the number of unpaired electrons, when you fill this arrangement, find the one that is not paired. Like this one is one unpaired. And you can go ahead and you can say, what's the number of unpaired electron in calcium positive charge atom of electron? Positive charge atom. What's the number of unpaired electron in calcium ion? You can find it. Let's do for calcium and maybe one of these and then we are off. For calcium, calcium plus 2 is now, before calcium will become a plus 2, calcium needs to give out 2 electrons. Okay, by oxidation. Now, 2 minus 20. Calcium is 20, so 20 minus 2 is 18. So there's 18 electrons remaining. So what I have here is 1s2, 2s2, if you follow this structure, 3s2, 3p6. You know that the p is threefold. What is the p? 1s2, 2s2. This is 2p. Making a mistake. Let me do that. Mistake is good. It's good, so you learn. So let's start again. We have 1s2, 2s2 is 18. I hope you know it's 18 now. You should know that. We are going to 18. 1s2, 2s2. After the 2s2, what do you have? 2p. So we have 2p, 6 now. We are going to 18. 3s2. And then over there, what should we have there? I don't need to have any distraction. Let me clean up all this so that you can see it very well. I'll do it again. Calcium. For calcium to not positive charge, this calcium needs to give out 2 electrons. Do you see that now? Okay, let's make a space. So it is 20 minus 18, okay, for the electrons. Now, we now have 1s2, 2s2, and then from this arrangement, the next thing is 2p6, the next thing is 3s2, the next thing is 3p, what to give me 18? 6. Okay? Now let's fill it. Let's fill it in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. See that? Okay. Now that is the electron configuration for calcium, which now become 1s2, 2s2, 2p6, 3s2, 3p6. Okay, if you count it now, this is 10 plus 16 plus 2 is 18. Now, why is it 18? Because it has lost an electron. It becomes an isoelectronic element with the noble gases. Alright, become an isoelectronic element with noble gases. So if we have done something on isoelectronic configuration in our previous class on the particular nature of matter. Anyhow, you can check that video for that. Now, this is all we've got for you. If you have a question, okay, you can solve this and solve this and also solve this. Try out that at home. We're waiting for your answers in the comment section. Thank you very much for watching. Please don't hoard knowledge. When you see knowledge, try and send it out to other students so they can be able to also pass the exam. Because one person's success is the success of all. I pray admission for every one of you all in Jesus' name. So see you next time. Remain blessed. Thanks.